Hey, what's going on, guys? In this video we are going to see how to derive Schrodinger's equation. Now there's no correct or mathematical way to derive this equation, but we have to kind of take a leap of faith and hope the assumptions are correct. Now here you can see this is the general mechanical equation and the terms are like, let's look at this one. This is amplitude, this is the wave number, this is position, omega is the angular frequency, t is the time, and k is given by 2 phi over lambda, omega is equal to 2 phi f. Now we had to bring this mechanical wave equation into complex exponential form, because we had to bring complex exponential form in order to derive the Schrodinger equation. Now from this mechanical equation general mechanical equation, we can only derive the real part, but however we had to move to the complex part and then we had to solve for this one, like we had to derive the Schrodinger equation. Now let's see how we can derive the real part. Now in here we can replace this k and omega with k with 2 phi over lambda, omega with 2 phi f. Let's go ahead and do that. This is going to be y of x comma t is equal to a cos. Instead of kx, I'm going to replace this k with 2 phi over lambda. So we are going to have 2 phi x divided by lambda minus, instead of omega, I'm going to plug 2 phi f. So this is going to be 2 phi ft. Now I want to take this 2 phi f outside. So in order to do that, what I'm going to do is I'm going to multiply this 2 phi f in the numerator and f in the denominator. In that way we will get y of xt equal to a cos. If I multiply numerator and denominator by f, this is going to be 2 phi fx divided by f lambda minus 2 phi ft. Right, here we can take 2 phi f outside. So a cos 2 phi f. If we take 2 phi f, this is going to be x over f lambda, and here you can see v is equal to f lambda. So we can replace this f lambda with v minus 2 phi f we already taken outside, so this is going to be just t, and 2 phi f is equal to omega, right? Omega is equal to 2 phi f. So we can replace this 2 phi f with omega. So this is going to be a cos omega x over v minus t. Now if you look at this one, here we have a e I omega x over v minus t, right? This is a complex exponential, and if you use Euler's equation to write this one in terms of cos and sine, you are going to have an equation like this. If you expand this one using Euler expansion says when we have a complex exponential, that can be written as y is equal to a cos omega x over v minus t, and plus, this is real part, this is imaginary part, is going to be sine omega x over v minus t. Okay, so this is the Euler expansion of this complex exponential. Now if you compare this one, this part right here is the real this is the real part that we derived, but we need complex part in order to bring the Schrodinger equation. Now let's go further from here. Here we have y is equal to a e power I omega t minus, we just reverse order this one. This is a e I omega x over v minus t. If you take the negative sign in front, this is going to be switch around, right? T is going to be in front minus x over v. We need this pattern because finally we have to derive the Schrodinger equation. That's going to look like something like this. Now in order to derive this one, we need these three equations. E is equal to hf, h is the Planck's constant, f is the frequency, lambda is equal to h over p, h is the Planck's constant, p is the momentum, and also h bar is given by h over 2 phi. These are the three equations we had to know in order to derive Schrodinger equation. Now omega, we can replace that one with 2 phi f. So let's go ahead and do that one first. So this is going to be y is equal to a e power negative I. Instead of omega, I'm going to replace that one with 2 phi f. So this is going to be 2 phi f t minus x over v. Now what I'm going to do is I'm going to bring this f inside of this parenthesis. So we are going to have y is equal to a e power negative I 2 phi and ft minus fx over v. Okay, so this is what we have right now. And also I want to bring these patterns, we have to have h. So in order to bring the h, I want to bring h for both of them, because in Schrodinger equation we have to express our final answer in terms of momentum, energy, and position and time dependent. Those are the 4 things we have to know, like we have to have in order to bring the Schrodinger equation. Now if you look at the energy, it has h. If you look at the momentum, if we rearrange this one, we have to have an h. So we have to have h for these two. Like in order to bring the h, what I can do is y is equal to a e power negative I 2 phi. If we multiply this one by h, we have to divide because we don't have h. H over h is same as multiplying by 1, right? So we can do that. hft over h minus fxh over v. I mean h. I'm multiplying by h, and also v is also there. Okay, and that's it. So this 2 phi. Now this denominator h is unnecessary because hf is equal to e. We can replace that one. This p is equal to, if this is lambda is equal to h over p, this is a de Broglie wavelength equation. But if we rearrange this p, that's going to be h over lambda. So h over, we have v is right here. I can replace this v with f lambda. Okay, let's do that one, and in that way I can cancel this f2. Okay, let's do that one. Y is equal to a e power I 2f 2 phi, and I'm moving this h in front, this denominator h inside. I moved this one to the front. So here we have this one, and this one, all of them are power, right? All of them are in the power, so we shouldn't forget that one. Negative I 2 phi over h, and here we have h ft. I moved the denominator in front, so we don't have denominator anymore, and I move this h denominator front, so we don't have the denominator h anymore. This is going to be fxh. I can replace this v with f lambda because v is equal to f lambda. I can replace that one with f lambda. From that one, ff cancels, so we get this one. Now let's write this one. Let's use these equations. A e power negative I 2 phi over h, hf is e, so this is going to be et minus h over lambda. H over lambda is equal to p, so this is going to be px, right? So in the final answer, we want to have the equation energy dependent, like function of energy, function of momentum, and time and position dependent. That's what we have right now. So we are almost done. And also final thing what we can do is, we can, this h bar is equal to h over 2 phi, but here we have the reciprocal. We have 2 phi over h, so this is going to be what? This is going to be y is equal to a e power negative I divided by, if it's h over 2 phi, we have to replace that one with h bar, but if it's 2 phi over h, we have to divide this one by h bar, and also here we have negative, so the h bar and power et minus px, and this is going to be the final derivation of the Schrodinger equation. And that's how we derive Schrodinger equation. And here you can see the 4 things you have to verify. This has to be function of energy, function of momentum, time, and position dependent. That's all we need. I hope this helps. Thanks for watching.